All right, hello everyone. Thank you for being here today. You're at a concurrent session titled Brain Models of Consciousness. We have 6 speakers today. Each speaker will have 20 minutes to present with a 5-minute Q&A, so we ask that you hold your questions till then. And then our assistant here will be running microphones around the room, and I have a series of warnings about time for the presenters. All right, so without further ado, our first presenter is Jan Treur. Sorry for the poor pronunciation. Multilevel Causality, Reification as a basis of higher order self-representation, a dynamic, interactive, adaptive, and evolutionary perspective. Let's give him a round of applause.
Thank you. Okay, thank you for having me here. It's very nice to be able to talk here about some of the ideas we have. This is from this is an overview. I'm working in AI partly, but I'm also sometimes a bit in philosophy. And in AI we do causal modeling already a long time, but in previous times it was a bit more primitive and now it's more advanced. And I will tell you about that first, and then later I will come to the concept of causality reification. And then after, in the second half of the talk, I will put it more in the context of different philosophies about representations. And I end with the idea of self-conscious and self-explaining AI. Okay, yes, as I said, in early history, causal modeling in AI was just static causal graphs, and then they could do some diagnosis, for example, on that. Later on, they came with node activations of such a graph that were dynamic, which has activation values. And recently, we added reification of causality for such networks and based a self-modeling network modeling approach on that can run such things. So we have done a number of applications of that already. And one of them is, for example, the case study that I will show as first one. So first the causality reification principle for our mind. Later on I will show also options for it, not only for the mind. The case study is with a colleague from psychiatry, Gerrit Glas. He did a lifetime of being a therapist in different contexts, but he was also a full professor at my university part-time, so I found him and we just were looking at this type of things to see how that works in therapeutical situation. He has a lot of publications and also a book about his human-centered types of therapists, where he explains his idea. Well, in this case, for this case study, he provided such a case study which has a realistic background. And then the idea is that within a therapy, you try to get people first familiar with their own personal characteristics, to let them know themselves a bit better, becoming aware of some important aspects of them, and being able to interpret one's behavior in relations to those aspects. And finally, based on such insights, the idea is that the therapy would lead to being able to manage oneself more effectively. So that's the case study that we started with. So the idea of his writings was already that he has a kind of 4-level architecture in mind, where you have the base level mental process, then you have a level of self-referencing, a level of self-awareness, and a level of self-interpretation. So we try to follow these as well as possible. So this was the idea of the model that came out. So first, this is not yet the model itself, but just a kind of, yeah? Okay. So this is just an example. Am I now in the way for you? You see, this is a base network, and it is not yet a case study. But for example, in this case, the states X3 and X5, they have some causal relation. So X3 has an influence on activation of X5. And then the self-modeling idea is that you make a kind of small picture of the network inside the network itself. So the part of the network structure is this connection from X3 to X5, plus how strong it is. And W, the W of it is the state that represents the weight, the connection weight, the number, the value of that. So that is things that we can use. And so this is then the first level of self-representation. There are causality strengths, but there are also the knowledge about causality strengths and this knowledge about how you relate yourself to that. So that's the idea I myself have a strong impulse to do this when this happens. And that's what he calls self-referencing representations. So the next level is about self-awareness, because having self-representations is not automatically needed to be aware. And then we have self-awareness states, and if you look well, then you see dashed bidirectional arrows between them. That means we used the idea of the winner takes it all principle, which is also playing a role in some of the well-known theories on consciousness. So that means that one of them wins that in competition with the others. So then we have the idea of making certain states more accessible, more excitable, and that you can do that by thresholds, and that's represented in those states. And this kind of intervention there, I will not tell the whole story, that will be too much detail. So in the highest level, we have some focus state. Actually, it was also in the next higher level. That means that we include some form of attention. By focusing in the therapy on certain things, you make more attention, and attention is, like in the theory of Graziano, one of the elements that can play a role in consciousness as well. So that's the highest level there. The person is trying to interpret him or herself and to find out what is not so practical what I'm doing. Maybe I can change some things. And that can be going downward with the long pink loop downward. So this is a bit of the idea. I will not go into too much details. I will now focus on more bringing it in the context of the ideas about representation. And I will go through these types of things that I mention here. One first thing that may not for everybody be related to representation, but still can be seen as that, is the idea of dynamical systems as state-determined systems. That means that the current state is determining the future behavior. So in that sense, if you say it explicitly like that, it can be viewed as a form of representation of the future. SB has written some interesting thing about that too. He said that usually you are looking for concepts that make your system state determined as a researcher. So I found that interesting, but he doesn't do much more than just this remark with it. But later I try to find out what is really behind this, and if researchers just are looking for it, is that meaning that they are in the world as well? So that's the next question related to this. So state determinedness has a kind of asymmetric position in time because it relates to current and future, but not the past. And so there are also ideas, of course, that the past plays an important role in the same way, more or less, like Laplace, that is really a symmetric formulation, actually. And also the interactivist representation, one of the earliest works of Mark Bickhardt, was also talking about the past, and that relates to the current state, and that has effect on the future. So that's also someone who put both sides already in one picture. So a number of years ago, I tried to formalize that in the term temporal factorization, and I will explain it in a bit more detail now. Suppose that you have part of the world where the past determines the future. And so this part of the world is assumed deterministic. The rest may not be deterministic, but may as well be deterministic. And so you have some kind of causal effect of past patterns on future patterns. Then temporal factorization says, well, it should go to the present. So break it up and put the present state in between. And that's what I call a mediating state. It mediates between past and future and is there in the current, in the present. So that is some form of world structure. It's a world state, but it's a form of structure in the world that is there. That is kind of transfer possibility from past to future. So you can see this as the left-hand side is a causal relationship from past to present. The right-hand side is a causal relationship from present to future. And you can also say that this is a form of representation relation from the past and the other one to the future. So like some of my previous mentioned people also suggested. So that's the idea then. This is an example that I sometimes use to explain it. That's the river metaphor. Suppose that you have a river with some flow of water, but of course that depends on also other things that have been there in the past, like erosion. So there is a past pattern of erosion and after that a future pattern of the river flow. And of course we know what is in between is the riverbed. So the temporal factorization is just the riverbed as mediating world state. So that means this temporal factorization principle may work in the brain. One of the other options as examples is like delayed response behavior. If you see that, it can relate to there should be some memory state in between. Past things have influence on how you behave later, even if you don't see it. And that was like 100 years ago a research area for animal behavior people. So that's the idea of temporal factorization. In 2013, Peter Tse came with his book, where also free will was in the title, which was maybe not a good idea because it attracted a lot of maybe wrong attention, because there are still in this book quite interesting things, even if people criticized him about free will, which is in general a bit easy maybe to do that. But the idea of his concept is criterial causation, which is actually an example of temporal factorization, which I also will show. So his idea that there is some kind of changes in the neuronal circuit based on the preceding processing, and those define some type of criteria that are on the one hand physical, but also have some content as information. Because that gives the information not only about the past, what happened, but also about the future when activation will happen. So that's actually just an example. This is his formulation. Is an example of also such a kind of intermediate state between past and future and some representational content of it. So this is then a past representation relation, and this is then his future representation relation. And it's clear that it maps quite well on the idea of temporal factorization. I wished he would have referred to me, but probably he didn't read it. So that's a pity. Let's now look at the causality reification, because that was one of the main concepts of today. And temporal factorization in general postulates states in the present mediating between past and future. Causality reification states can serve as one specific type of that, where you have the same type of mediation. So we will now move a bit more from the mind to the world. It's possible that not only in the mind, but also in nature, this principle can be found, and where you have causality reification. So let's check it here. This example fits well also in Peter Tse's perspective, at least the lower part of it. Suppose you have, you look at activations of neurons, and there is some dynamics of synapse strengths, learning say. Then there are world states. These are structures in the brain that make this mediation. So this mediating world state is actually the criteria that Peter defines as representation. But you can also add one level on top of that, because there exists also something like metaplasticity, which controls the amount of the extent of plasticity. And then you have a world state where there is the mediating state for. So you see that there are states, structures in the world, states that concern structures that are created in certain ways that play this role as mediating states and create levels here in this case, for example. So levels is also what Birch and Bechtel from philosophy of biology describe. There is the area of mechanistic explanation. They is often seen as opposed to causal explanation, which is not completely true, I think. But they have found that in biology, often mechanisms that you look are not producing anything, they're just control mechanisms, and often even multiple levels. So that's recently they came out with such ideas, and that was also very interesting in relation to what I was doing. And so I have a case study 2 here for the few minutes that I still have. The idea is that there can be some circumstances, childhood neglect, for example, that makes your epigenetic things different, by which the expression of the genes is changing, like from low or to high or from high to low. And that disturbs your normal functioning. And that results often in many mental disorders. And these are the green ones that are finished, and the other ones are still working on. We use also these types of things as case studies. And Nick, 2023, is a very nice paper about it. He shows that disorders in general, they relate to such type of patterns of history. And his second idea by it is that self-control is often the thing that is disturbed if things are disturbed in mental disorders. So also here we have a lot of control levels, and in this case we follow in biology, of course, you already have a long time that you have the DNA gene expression. They create mRNA that controls the enzyme production, and enzyme controls the physiological development. So those 4 levels we could just already take over. We added the epigenetic level on top of it, and we also added downward a level to distinguish mental processes from the brain structure. So what happens here is also they influence each other, all these processes, dynamics, you have those relations. And then you also have structures. So there are all kinds of structures that make these things happening. These are all mediating world states between those processes. So this is one of the models that we created for it as a self-modeling network model, where we could model this in detail, at least to a certain extent, because it was also abstracted a bit. So that's then we already have an example of many levels, many orders of self-modeling. So there are 2 ideas that have some relation to this. There is the frozen metabolic accident principle for evolution that says if there is some complex structure developed in evolution, then it's difficult to put it away, because it should be replaced by something which can take a lot of time to develop it again. So that means that many interesting and complex things, they are frozen, and the thing is that they are only controlled instead of that they are modified. And that automatically leads to a kind of stacked structure. Another thing is the the idea of metabolism. First principle that says, well, the origin of life comes from metabolism, then they start to control it in a simple way, the control becomes more complex, it became more control, and so on. Well, the ideas that I present today fit also well to that, I think. There is one thing that I can just mention here. This is a very sad situation. Albert Hofstadter, who actually was the uncle from Douglas Hofstadter that we may know, had a very interesting paper in the Journal of Philosophy, only 3 citations. I will cite him now, I will be 25 of his citations. It's also a pity. But I think his topic is a bit, people are often criticizing that. It's similar to the idea of the world of idea of Plato, that there is some abstract structures are there, actually nowhere, but they are not in the world, and that's the criticism then often. But this fits quite well here, because what happens here, what we do, we have a kind of world of potential causality ideas, say like the causal diagrams that you can imagine. And what evolution does, evolution is just a very intensive process of searching and finding things. They just they generate all possibilities, and sometimes they find some of the ideas of this, what I would call causality ideas. So that's another way to see it. And one last remark is the idea context-free versus context-dense. Physics started with the idea that you need empty space to just have laws doing things for you. But we work often in dense context. Our brain is dense, many biological things are dense. So from physics, from that time, that would be only disturbing. But what you really see here is the dense context is used for the evolution to create more and more things, to create extra causality in the world. And the causality is not in the laws, the causality is in the world structure. So that was then the insight that you can keep from this. Okay, last remark. Of course, for the future, we are looking for self-conscious and self-explaining AIs based on such ideas. And maybe in another time I can present some new things about that. If you are interested in joining me in this work, I am very easy in collaboration and do it often. So if you think about a case study, for example, you can always contact me. In next year or after next year, we'll try to get a book out of it. Okay, thanks.
Time for 1, maybe 2 questions.
Does anyone have a question?
No, nobody dares.
Yeah, really interesting stuff. I was curious, like, what you think is actually implementing these, like, layered causal structures, and you did kind of get at it with the enzymes and, like, epigenetic regulation and stuff. I guess I was curious I thought it was curious that the epigenetic factors were maybe, like, the highest level of influence, and to me, like, it seemed a little inverted, where I would expect neurons or these kind of more recent information processing structures to maybe be at higher orders.
Yeah, the biologists, they count already always from the DNA to the mRNA, so they count in this way. So we take into account what the ideas are around, and if you have different ideas, you can do it differently probably.
Interesting, yeah. Any other questions? All right, one more round of applause for Jan. And our next presenter is Silvia Paddock. Her talk is Flipbook Idealism, a discrete idealistic approach to consciousness.
Thank you very much. Okay. Yes, I just blocked my brother. Yes, thanks a lot and good afternoon. My name is Silvia Paddock. I'm here together with my brother, Thomas Burvenich, to introduce flipbook Idealism. When you're a neuroscientist, as I am, and you are an idealist and you speak about it openly, you're either self-funded, retired, or dead. So I'm in the first category. Here representing my brother's company, Taletekk in Germany. A little bit background about us. So we're a neuroscientist and a physicist working together. We got our respective PhDs in 2002 from Karolinska and University of Frankfurt, respectively. We are siblings and no worries. So this is not the, consciousness is weird and quantum is weird, so they must have something to do with each other kind of presentation. And this is not about quantum consciousness. Rather, if your model of the world is wrong, if materialism is wrong, then any scientist will hit a wall eventually. And so we just got together and really appreciated exchanging ideas and working with each other and helping each other over a long period of time. This really started in high school. And finally, 30 years later, a couple of years ago, we wrote it all down in a book that's called Plato's Prisoners. And we're very humbled that Joe Edwards actually reviewed our book in the Journal of Consciousness Studies. So that was in early 24. And also very happy that our model is included in Robert Sloan Kuhn's recent seminal review of models of consciousness. So also there you find a reference to the book. It was very interesting. In the previous session, we heard that if you can't measure it, then it's not science, right? And the hard problem of consciousness has been with us since Galilei. And what Galilei did was, and Philip Goff has pointed this out many times, right, is to put up this wall, right? On the one hand, you have the things you can measure, and everything that is subjective experience, qualia, our conscious experience, right? We put this on the other side of the wall and pretty much ignore it, right? So that's non-scientific. So science is what we can measure. And the hard problem is written from the perspective of materialism, right? So materialism says that there's stuff, and now we have this hard problem that we have to explain how consciousness emerges from the stuff, right? It's not written from an idealist perspective where we say we have consciousness and how do we get to the illusion of an actual outer world. Yes, physicalism in a nutshell is that consciousness arises from brains, and brains are coherent physical systems. And this is by Jean Carroll. I love Jean Carroll. I learned so much from him. But he should have a sister who's a neuroscientist who could tell him that this first statement here is actually completely unproven, right? This is where this, I think, falls down. Okay. My brother will speak more about this. So then the question is, how far have we come in our endeavor to understand consciousness? And this is, of course, depends on what your everything is, right? So for Jean Carroll, who worries mostly about how high a ball bounces and measuring things in his daily life, he says that, okay, it's all explained, right? We're done. Donald Hoffman, who is also an idealist, of course, says they're betting zero, right? So when it comes to understanding why chocolate tastes different from broccoli, why pain is different from the sound of a violin, we have not made any progress, right? So that's the divide between the two approaches here. So materialists say very often that brains generate consciousness like kidneys generate urine, right? And okay, that's a hypothesis. Let's test this hypothesis, or let's use this hypothesis to understand consciousness. So so you have the picture here of the cell, right? And somewhere in the cell there must be a molecular machinery that explains our conscious experience, our qualia, our inner world. So how does this work? We have no idea, and we don't even have a good hypothesis. But for kidney and for many other diseases, we have understood a lot of the function based on loss of function. So we've taken people with diseases, people with traits where the function is disturbed, and looked at those and used this approach to understand the function. And so I'm a neuroscientist, and actually my background is in neurogenetics. So I did genetics for most of my time in neuroscience. And so I think that neurogeneticists to the rescue, right? So if there is no good hypothesis of what the genes could be that account for this molecular function, then let's take our neurogenetics approach, where we just take DNA from people who have the trait and compare it to DNA from people who don't have the trait. And then we see what the DNA mutation is, and from that infer what's the molecule, what the function of the gene. And that worked extremely well, for example, for Huntington's disease, where we had no idea how this worked until we found the mutation, we found the gene, identified, and now start to understand the disease process. So this falls on its face remarkably fast, because the first step in such a research program, so a materials research program to understand the conscious experience, is to find people who are colorblind, deaf, insensitive to pain, but who do not have mutations in the sense organs, right? Because we know that conscious experience is not, or it doesn't originate from the sense organs, right? So we go out there and say that, okay, let's find colorblind people, deaf people, people insensitive to pain, who don't have mutations in sense organs. And then we quickly find that there are no such people. So we have a lot of people who have mutations in the retina, all the rods and cones mutations and so on that lead to color blindness. We have a lot of mutations in the middle ear and the inner ear and so on that lead to deafness. Once the signal gets into the brain, it never fails. And that's quite remarkable. So we've hit a bit of a wall here with our neurogenetics approach, because this idea that we take people who can see color and people who cannot see color and just compare their genes falls short in the very first step, that there are no such people. And now I've been going around and asking people this question, why are there no such people? And people just will say that, oh, I never thought about it, or is that so? And that's a bit odd. So the usual explanations that people then have is that either it's embryonic lethal, that seems unlikely because colorblindness is completely viable. There should be at least 2 colorblind people in this room right now, given the male dominance at a conference like this. It's also, another idea is that it's highly backed up, but at least as a complex trait, it should exist then. Then there's identity theory, right? That the signaling of the neurons is conscious experience, and there is no molecules under there. But then that kind of kills the kidney and urine hypothesis, right? Because for kidney and urine, it is molecules that make the urine, right? So the brain would be very different from all the other organs, right? If we say that, okay, just the neuronal firing patterns, that is conscious experience, and you will never drill down, you will never understand it at a lower level, right? And the final hypothesis then, of course, is that the phenomenological experience of color is non-materialistic, non-physical. So it's also often said at this conference that, there's no magic needed, right? Ultimately, consciousness will be explained, just like life was explained, right? So no élan vital was necessary for life, right? And the same will be for consciousness. It will, just be, regular material stuff, right? But also here, I want to point out that to study life, that's easy because I can take living things and compare them to dead things, and I understand the difference. What differs between the living thing and the dead thing? I understand life. But here, again, we have no probants, right? We don't have these people who are cortically colorblind, so we cannot go further here. So then, while the materialists are stuck and have to come up with a new research program here, Let's think about other ways of explaining our conscious experience. Now, of course, that then, if materialism is wrong, that one alternative is idealism. And so my brother and I developed flipbook idealism, which is new discrete idealism. And what it has, and this can only be a collage of this, because again, it's a lot of different aspects and thinking and math that go into it. But just very roughly, our idealism shares with other idealisms that consciousness is primary, consciousness is the ground of our being. So in materialism, you start with space, time, and matter, and then everything else originates from there. While in idealism, you have consciousness, and then consciousness reads out patterns from a common data source and generates an experience of a world. And so in this case, the external world is the illusion, while in materialism, at the end of the day, consciousness has to be the illusion. So this is where we differ. In flipbook idealism, brain patterns, and this is why we're here in the section about brain models of consciousness. So it is brain patterns that are read by the universal consciousness that lead to conscious experience. And we call the data source, the common data source that we all use, the Urgrund. And this is, Stuart Hameroff said that I'm not an idealist, I think there's a reality out there. Yes, there is a common data source, there's the Urgrund, but it doesn't mean that there has to be a physical reality, actually, that we're standing in here. Yeah, so brains are structures in this Urgrund, and then if you poke the brain, right? So if you stimulate the brain, and then consciousness reads out an experience based on that pattern, then you will see that there's nothing you can do, no way you can poke the brain and elicit an experience that would prove materialism right, because it would be the result would be the exact same also in idealism. So just having these correlations is not going to break the tie. One more advantage of idealism is that it's non-local. So we don't have the neural binding problem. So materialism, because it can read out patterns all over the Urgrund without being restricted to what in space-time then is adjacent to each other, it might explain why we have this immersive integrated experience from signals all across the brain that we don't understand where they would actually come together again. Now, all of this is a bit abstract, but also at this conference there's a lot about brain-computer interfaces, so I want to use this analogy to explain what this looks like. And this could almost be done, right? So imagine that we take your brain and we connect all kinds of neural links to it, and then provide your conscious facilities to a program of evolution. So there's a computer that runs a program of evolution, and now these structures here in the computer get to utilize your conscious facilities. And this is also, I think, we're quite aligned with what was said yesterday in the session about consciousness being fundamental, and consciousness also, that consciousness helps evolution, because consciousness has this drive to survive and to thrive and to create more and more complex creatures. So after a while of playing this game, there would be all kinds of structures evolving in the computer that make use of different conscious facilities of yours. And eventually, some of those would become quite complex, like human-like, right? And then they think they're separate from everything else around them, right? Because they have kind of one conscious bubble of your total conscious facility. And ultimately, they would realize that, wow, we're in a computer here, right? Everything around us, we understand all the laws of this machine, right? So, yeah, everything here is just deterministic. There is no free will, right? And we're all just machines, right? not understanding that their consciousness is part of the global consciousness, right? So in this case, your consciousness is the substitute for the universal consciousness that we have in idealism. I mean, imagine we could be in such a simulation already, right? We're not that far off, right? And maybe one day here, no, one day in some other life, right, is a whole lifetime here that we spent in this program, right? And then our real consciousness would look like an idealist universal consciousness. Okay, and then again, I want to ask my brother to help me highlight some of the physical aspects of Flipbook idealism.
Okay. Thanks a lot, and good afternoon. Thank you. I will just add a few points regarding how Flipbook idealism aligns with current physics understandings. Imagine people who thought that, many decades ago, hundreds of years ago, 1,000 years ago, if you go back, that the Earth is flat and is fixed, and you have the sun, the moon, and the stars revolving around it. Then you can ask, why did people think that? And one might come up with the easy answer, yeah, because it looks like this. Yeah, but now we know that the Earth turns around, and the sun is fixed in everything with respect to the Earth, and it still looks the same. So why did people think that? Because they had hidden assumptions. Yeah, they thought the Earth must be fixed. This is where we are. This is how God created it, and everything must turn around. So we had assumptions, and another assumption is that which we still had, is that we live in a common bubble, or in a common, let's say, aquarium altogether, in a common external reality. And why do we have this assumption? Why do we think this, or why did we think that? Because it looks like it. But then came Einstein and probed this assumption by going very close to the speed of light. And if you go very close to the speed of light, it looks quite weird if you still think we're in the same aquarium. Yeah, you probably all know this, a situation with a train which goes by. Let's say you stand at a platform, train goes by with 100 kilometers per hour, a guy in front of it throws a ball with 30 kilometers per hour, then for you, the ball flies away with 130 kilometers per hour. The velocities add up. Now imagine the train being at 30, let's say 90% of velocity of light. The guy, very strong arms, throws the ball with 90% of velocity of light, and you're at the platform, still see a ball flying with velocity of light. So that's very counterintuitive. And we thought maybe there's a more deeper understanding why this is so. And we believe that Flipbook idealism actually gives the answer, because we are not living in the same bubble. We are all, thank you, creating our frames by ourselves, by probing the Urgrund, and then making a projection of space-time physics by certain laws. And one of the laws is causality, and light speed is the limit of this causality. So we all have the same light speed because it's our causality which we experience in our reality. Maybe we can go to the next slide. And this is what is pictured here. Silvia mentioned this already. We have the Urgrund, which we probe by question and answers. This is like a quantum measurement, for example. And then we make a space-time projection based on certain laws. Like, for example, causality. We project this into a space-time structure, and then we gain these discrete frames. And going from one frame to the other is what we experience as a flow of time. So in our picture, time is qualia, which we experience when we go from one frame to the next frame. And this is how we believe that we have some more intuitive and maybe even deeper understanding of some of the findings of physics, which look counterintuitive if you don't have this picture of your own frame generation, of your own seemingly external world which is created as a projection by yourself, by your consciousness, actually. And that's all I want to add. And I hand over to Silvia again.
So yes, and I will bring it back to the brain because brain waves are at 17 something hertz, depending on your awareness. And of course, that is quite slow. That's something that we got from evolution because we ran away in the savannah from some animals, right? But the universe can generate frames down to Planck time, right? So much higher frame rate. And I think it's interesting because normally I would, so a couple of years ago, I would have a Christoph Koch quote at the beginning, like some kind of materialism quote, and then kind of argue against it, right? And now Christoph Koch has come around to become an idealist, right? Actually pointing out that idealism, this is from a recent podcast with Michael Shermer, idealism is the model with the fewer assumptions because everything comes to us as consciousness. So you can close your eyes and become aware of this maybe as an exercise. And then so what? So what are the consequences of this? So materialist cannot just say that, oh, I go where the data takes me, right? Where the data takes us is the next publishable unit, right? It's the next poking the brain, studying correlations, but it's not going to take down the fence, right? So materialists need to come up with some kind of research program that actually breaks down the fence to subjective experience. Poking the brain more and more is not going to solve this problem. Of course, the further development of our model needs to lead to testable hypothesis, otherwise it's garbage, so that's where we need to go, right? Idealism also needs, we agree, that extraordinary evidence is required for extraordinary claims. But extraordinary evidence needs extraordinary research budgets. And that's where the problem comes, because as long as you're considered complete fringe, you're not going to get those budgets in order to prove your point, right? And and then some people have taken psychedelics and then kind of come around to idealism. That can be a little bit dangerous because of confirmation bias, right? Once you have that noetic knowledge, right, then you go like, oh, I know how it is, right, and now I just have to prove it. So we really have to be very rigorous. In the meantime, where's the money going to come from? There is money in this because I think that there's billions and billions right now invested in longevity, where you add lifetime at the end of your life, right? But this is kind of bad, because you're old, and anything you do is going to be kind of slow. So with this model with the frame rate, we can say that, hey, let's add quality lifetime in the middle of life, right? Let's expand consciousness. Let's increase our frame rate so that we can have a lot more experience during the lifetime that's given to us, right? And so, yeah, I think that's a good idea to invest in, and then we can use the money to further the idea of idealism. Okay, and finally, final words. So, as Thomas said, we thought we were in this cupola and Earth is flat and everything, and still someone cracked it open and said that, look, there's like 1 billion galaxies out there, right? This is a small part of what we can see. And we think that consciousness is indeed the next frontier. So we thought it was a wet machine. That's not true. And now there's an unbelievable, an unbelievable new opportunity to study a re-enchanted world. So thank you very much.
Maybe 2 questions. Sorry.
You pick.
Okay. Yeah.
Terrific talk. Imagine that a billionaire was in the room and they were like, I'm persuaded, here's a check, what would the study be? They might be sitting here, you never know.
Yes, I think that, so what my favorite project would be that, Oliver Sacks, he reports of these people who are blind and get these hallucinations of sometimes different cultures like Japan or something like this where they've never been, right? And now with Google Earth and everything, right, we can test these things, right? We can systematically trace this down and find, is this actually, you know, someone else's memory or someone else's reality right now, right? So when these connections break down, right, I think with very big budgets, we can do this very systematically, not just anecdotally, right? And then prove the point. Yeah.
Thank you.
Okay. Okay. Yeah. Next one.
Would blind sign be a proband in your classification or not?
Be a problem?
Blind sign patients.
Yeah. Blindside.
Patients. You said that there are no probands for consciousness studies.
For color blindness, yeah.
For
so
color
complete,
blindness,
yeah.
yes. But if you'll take a blind side,
People who
Who are blind, but
blind
yeah.
still are going around.
cognitively behaving accurately in the situation, denying that they're consciously experiencing phenomenally anything.
Yes, we should sequence.
Visually.
We should sequence them, see what's going on, right? I mean, absolutely, yeah.
I mean, that will be a proband in your classification for this type of experiments.
So, I think that yes, that could be very interesting to study. Yeah.
Yeah, thank you.
I think most of these people have some physical damage, but yeah.
Thank you.
Okay.
All right, thanks so much. One more round of applause for Silvia and her brother. All right, well, hello. I'm introducing myself. My name is Justin Riddle. I'm a professor at Florida State University, and the work I'm presenting today is also in collaboration with Jonathan Schooler, who's at UC Santa Barbara, and I'm going to kind of set up our model of consciousness a little bit and discuss some implications of one component of it, and then Jonathan will dive into another component in a few talks here. All right, so the talk today is Consciousness is Slow at the Top, investigating the electric fields at the apex of the hierarchical brain. I'm going to be basically making the pitch that maybe consciousness is slower than we have given credit to it, and I will propose a couple studies that we have in the works to try to validate this theory. All right, so a quick outline of what I'll talk about. I'll introduce the nested observer windows model. This is the model that Jonathan and I put out last year. We'll discuss some of the mechanisms related to this model, and then a few studies that attempt to probe this low frequency component, and some comments on some future directions. So to kind of set up the motivation of our model, we observed that there are many different approaches from the domain of neuroscience. You have people studying molecular pathways, protein reactions, genetics, epigenetics. There's people that spend their time looking at neural circuits, modeling how different sensory systems process information in these circuit pathways, circuit diagrams. And then there's people like me who do EEG and MRI research, and we're studying these whole brain, functional brain regions. And we're often fighting to make the claim that we are studying genuine phenomenon that actually contribute to the information processing of the brain. And the pitch of the nested observer windows model is, what if each of these various levels are meaningfully processing information, and there's some coordination of information transfer across multiple scales in the brain, and investigating consciousness or cognition at all these various levels is meaningfully contributing to our understanding of cognition and our place in the universe. However, a very strange component that kind of arose from our model in some ways against our will was this notion of the apex, this kind of macroscopic, very slow process in our biology, in our brain, that we call the apex. And I'll be diving into what is this apex, and is it real, and could we build some sort of evidence for its existence? This is the proposed to be a more macro, more slow scale than even brain regions and maybe even brain networks. All right, so to set up the nested observer windows model, I already kind of proposed this idea of a hierarchical brain, the idea that there is information processing at multiple scales that's occurring simultaneously. We use the metaphor of a mosaic tile, where it's an image made out of tiles, and collectively those tiles form an image. And here we propose that maybe this is a metaphor to understand what it's like to be within a hierarchical brain. We have regions of cortex that are made out of neurons. We have neurons that are made out of proteins. And all of these systems are kind of nested within each other. And does this biological nesting play any role in our psychology? And maybe we could conceptualize our experience, our cognition, as some sort of collage of cognitive components, and collectively they form the gestalt of our experience. And if we dive into any one of these kind of components of our experience, maybe we'll find nesting in the same way that we observe in biology, where if we dive into one of those components of our cognition, of ourself, maybe we see once again another set of mosaic tilings that comprise that system. So we employ 3 different metaphors in the now model. One of them is mosaic tiling. This is kind of the, the foundation of where a lot of the novelty in our model lies. But we also use this metaphor of a theater, the creation of some sort of gestalt perception, what we call an observer window. These are kind of the units in biology that are created. And then we also propose a mechanism for dialogue, or we use the metaphor of dialogue, where observer windows can speak to each other, communicate with each other. So I'm not going to go, for the sake of time, into all the details of this model, but I'll present a little bit of the mechanisms that we propose. So we propose that observer windows are created by synchrony, or at the very least, when an observer window exists, it exhibits synchrony. This is 0 phase lag, basically tight coupling between anything you can measure within the observer window. We propose cross-frequency coupling, essentially a relationship between activity in 2 different frequency bands. One frequency band is slow, corresponding to a more macro-scale observer window, and the other one being fast, corresponding to a more microscopic observer window. And cross-frequency coupling is a means of transferring information up and down these different scales. And then we propose a mechanism of coherence, which is a weak form of coupling where information can be transferred between windows. So this is basically a model of how you could study the hierarchical brain. And we basically draw from the field of electrophysiology, from electrical phenomenon, but we don't make strong claims about the mechanism itself. So check out our recent paper if you want to learn more about the details of the model. I'm going to dive into this notion of the apex. So what is it like to live at the apex of a hierarchical brain? Well, maybe you would have the experience of having ideas emerge into your mind fully formed without any apparent origin. Sometimes you're proud of yourself. Wow, I just had this amazing idea, and you go tell your friends. Other times you go, oh my God, who thought that thought? Let me suppress and repress this thought that has just appeared. But the idea is that this could be an expression of emergence, where ideas are being propagated into our theater of experience, and oftentimes we don't really know where they came from. They're fully formed. They have a lot of details that are, composing them. Second, maybe we're playing tennis, and we think to ourselves, run across the field, hit the ball. And this is a very abstract action plan that we're initiating, and then all your muscles are activating and all this complex machinery is happening, and yet we're not aware of, activate flexor, extensor apparatus. And when you have people that are professional tennis athletes, for example, they have these complex, nuanced motor initiation patterns, and they likely have no idea what they're doing either. They're initiating these kind of cartoon schemas of performance, and then it gets submerged down into these faster muscle groups and all this faster level of activity. And this is kind of a new-ish term, but obfuscation through binding. So because we are living at this very slow, macro, integrated scale, we oftentimes don't understand the origin of our own thoughts, the origin of our own cognition, and by binding all this information into your experience, this multi-perceptual, complex narrative experience that you're having, we lose source of all of these pieces and parts of our cognition that are potentially giving rise to our experience. And this might be why the hierarchical brain is sometimes not intuitive, and yet maybe if you introspect, you'll realize that there are maybe parts of yourself that often operate in different ways, and they manifest into your mind. We also have, in this tennis player example, there's some level of control over our bodies, but other times we don't have control over what our minds and brains are doing. For example, this optical illusion, even though you know this is a static image, your mind is generating optical illusions, and it doesn't matter what you're willfully trying to do with your mind. It's kind of happening nonetheless. All right, so how is the apex instantiated? And these are, a couple musings of how this might occur in our brain. One of them, and this is some speculation also put forth by George Northoff, B.U. Hay, and Marcus Reichel. There's something called the crowning mystery in neuroscience, where your cerebral cortex, that wrinkly gray matter around the edges of your brain, is assembled into 6 different layers. And the first layer, layer 1, basically has no functions assigned to it, and we don't really know what it does. It is very sparsely populated by neurons, and they have a lot of long-range projections across vast distances, and this makes it very challenging to understand the function of what layer 1 is doing. And people have thrown out the idea, maybe this is kind of the global scale of the brain, where it's not able to be localized into particular functions of any given brain region because it's necessarily distributed to some grand scale. So maybe in the now model, layer 1 of the cerebral cortex is kind of a candidate substrate for the apex. What does this look like functionally? B.U. Hay and Marcus Reichel, for example, put out this idea of the slow cortical potential. This is a big electrical flux that you can observe in electrophysiology. It correlates with big fluctuations in the functional MRI signal. And they propose that, this is a great candidate for consciousness because it is so slow and it's able to integrate over a large temporal frame of reference. Just as we have a lot of information being bound into this experience, this is something biologically occurring at a slow enough time scale to maybe bind all this information into one package, which you might need if you are a large, slow, lumbering creature like we are. All right, when do we see slow oscillations? So here's kind of the weird paradoxical challenge. So George Northoff proposes this as the paradox of low frequencies. Slow oscillations are present when you're under anesthesia, when you're asleep, when you're having a seizure. These are not great correlates for consciousness because in all these examples, you're not really conscious. And so the challenge with trying to study low frequencies is they have a deep, long history of being associated with strictly non-conscious experience. However, George Northoff makes the proposal that maybe nonetheless these low frequencies are still the substrate of consciousness, and maybe cross-frequency coupling between the lower frequencies to faster cortical activity is required for what we think of as normal consciousness. And when you're maybe under anesthesia or having a seizure, the low frequencies are present, but they're not meaningfully related to the other hierarchical levels inside of your brain. All right, how do we investigate the apex temporally? This is, there's very limited data out there. This is one study that I was able to find where they were looking at performance on a somatosensory stimulus detection task, and this is out of one of the PALVA's groups. Basically, a very light touch is applied to the skin, and when you look at the hit versus miss rate of feeling this somatosensory touch, you can detect this really low frequency fluctuation in people's ability to detect this touch. And they relate this to the phase of the infraslow signal between 0.01 and 0.1 hertz, and it wasn't related to amplitude, but strictly the phase. So where does this lead us to? So here's a number of projects that Jonathan and I have been brainstorming ways to investigate whether or not the apex is real and whether or not it's operating at this really slow frequency that maybe defies immediate intuition, but I think there's a strong intuition there. And I'll propose a couple experiments, and we're really looking for feedback. We plan on actually running these in the next year. So is there a flicker rate of your consciousness occurring at the scale of maybe once per second, once per 2 seconds, or maybe twice per second? And I'll describe a few ways of getting at this. So one, this experiment is, what if we presented a storyboard where there's a narrative that's being told? Here I just grabbed a storyboard of Spider-Man, but essentially we're flashing images and they form a complex narrative. And the question is there a certain rate where if we present these images too quickly, you're unable to hold on to and generate narrative for this storyboard, right? Is there sort of a preferred frequency of narrative? And maybe narrative is one of these ways that we can get at something that's very slow and that kind of lines up with our conscious experience. And then record EEG during this, look for oscillatory peaks in the slow frequency range, and maybe look for cross-frequency coupling to, what are traditionally the low frequency EEG rhythms. Another concept here is that when you look out at a beautiful mountain landscape, you're struck by the beauty, wow. But you're not really consciously aware that your eyes have to dart around and assemble all that beauty and then package it together and then give you that experience. So in this pitch, what if we record saccadic eye movements as someone studies a visual scene or a face, and then we take a video just of where the eyes are looking, and we play that at central fixation for someone? They should presumably, and there's been one study that's done this in the past, have a gestalt experience of seeing the entire image, and then we can scramble between the saccades as a control and compare to when there's no gestalt generated, and then look at EEG. Is there sort of a slow wave oscillation that correlates with gestalt perception, and then is it potentially coupled to higher frequencies? And then similarly with language, as I'm talking to you, you're not really paying attention to my words and assembling sentences, but you're being hit with ideas, right? It feels like you're just receiving idea, and you don't have conscious experience of assembling language from the syntax. So what if we took kind of Jabberwocky style sentences where phrases are kind of randomized, there's no gestalt perception of a sentence that's being generated by the speech, and then when there is gestalt perception generated by speech, is there a low frequency wave kind of tracking with the sentence structure of the narrative that's being played to you? And then similar analysis, look for low wave oscillations and coupling to higher frequencies. There's also a potential for brain stimulation here, so I do a lot of brain stim. Can we target the apex with electrical stimulation, maybe accelerate or decelerate the speed of low-frequency oscillations, and do we see a shift in subjective experience, maybe of time? But also, if we find some interesting signals in any of these approaches that I laid out previously, can we target this electrical activity and then see a change in gestalt perception or narrative perception? All right, so in summary, we've been studying a lot of fast phenomena throughout the history of neuroscience and biology. We study neurons, we study proteins. We're kind of like thinking of neurons as the top of the hierarchy, and then maybe proteins support neurons, and then neurotransmitters support proteins, and there's kind of this like turtling down and down and down. And we're, asking you to look up. Maybe there's a turtle's foot projecting through the sky that is standing on you as a scientist, And we should be looking at lower frequency phenomenon and maybe trying to look for neural correlates of human thought, human cognition in the slow frequency range. And this is really an implication that kind of came out of the nested observer windows model almost to some degree against our will. So here we are. All right, so thank you for your attention, and I'd love to take some questions. I also have a YouTube channel, so like and subscribe. Ruben.
Okay, we're going to start over here.
Justin, very cool. Thank you. I guess just a clarification to start with. Are you saying this kind of integrative apex slow frequency stuff is the seat of consciousness or the seat of narrative and thought?
Yeah, it's a good question. Yeah, as a cognitive neuroscientist, I don't think our experiments can answer that question per se. So yeah, I'll run with what I can localize at this point. I believe and think that we are very slow, and I think if you introspect, one thing that has kind of worked for me is realizing that the contents of your thought are very fast, and so we identify as being quick and fast creatures, but really the frequency of going through a train of thought or going through a coherent thought pattern feels a lot slower than I think people have given credit to. So my impulse is to draw, point at that as maybe the substrate of who we are. But it's a hard question.
Yeah, so I'll be very quick, but just to say that and we should just have a longer conversation about this. But basically, the apex of the hierarchy and hierarchical kind of processing is standard sort of neuroscience, right? And at the top is the narrative kind of ideas of default mode network, general kind of processing. But we're not our thoughts. We're not purely thoughts, right? And so then I thought the kind of next logic here in the now hierarchy would be that you can kind of tune in to different levels of nested observers to more fast versions, let's say through meditation or psychedelics.
Yeah.
And then otherwise we might normally be kind of stuck in this kind of slow frequency activity. So
totally, yeah. And we talk about that a little bit in our paper, where we talk about awareness and meta-awareness as maybe almost exclusively pointing towards faster phenomenon. And so self-awareness or meta-awareness of your actual rate of processing is maybe difficult/impossible, and we're only able to see reflections of ourselves at these lower levels. And so one reason why we don't think of ourselves as slow is because we spend all our time looking down at our brain at all the fast stuff that's happening, and we're not actually genuinely introspecting on the actual window that we're looking out of. So yeah, you totally nailed it. Maybe one more in the front here, and then I'll be around. So, or where are we at for time? When do I have to end? Oh, okay. Well, yeah, we got plenty of time. Okay, yeah.
Okay, thank you. Is now model applicable to other animal species besides humans? And if yes, is it applicable to birds? And if yes, how apex is instantiated without cerebral cortex at layer 1 architecture?
Ooh. Yeah, it's a great question. Yeah, I recently became a bird father, so I definitely have your question hits in a different way. But yeah, I agree. Another proposal which Tam Hunt has been proposing and some others are is maybe the substrate is just low frequency electrical phenomenon, and potentially there's quantum computers and other stuff I'm not going to lay claim on any of that, but maybe there's correlates in low frequency electrophysiology. But we do propose that maybe in animals there's a slowing down evolutionarily, where we are uniquely slow, and that contributes to our intelligence and our ability to problem solve. And so if you roll back the tape evolutionarily, you just get faster and faster creatures. And yeah, maybe there's some breakdown or limitations. We also think about octopi as maybe a novel central nervous system arrangement that maybe there's been some work looking at tentacle autonomy and how the tentacles are highly autonomous. And this might be a good example where the apex of the octopus is much more loosely controlling its body and fosters more autonomy in the lower observer windows. And so yeah, looking at exotic animals might be an interesting way to kind of test the model and how the hierarchy is maybe different, you know?
Thank you.
Yeah, interesting question. Maybe in front here and then go over there.
I hope this correlates with what you are talking about, but please help me with this. So Dr. Joe Dispenza has been collecting EEGs of people who are having unitive experiences, I guess is the best term I'd use.
Yeah.
And he finds that they almost mimic seizure activity. They're so rapid, but they are not seizures. And he says the ones he has collected are coherent. So do you relate to any of this when you talk about your...
Yeah, definitely. This is in the range of a lot of speculation, but I recently started collaborating with Daniel Ingram, Matthew Sackett, and a couple others, and we're looking at advanced meditators. Ruben also has a lot of experience with this, but no, Matthew's at Harvard. Daniel has his own foundation. Marjorie and Nifa are also working with me on this. But yeah, we're uniquely positing to some degree that maybe there's low frequency oscillations that correlate with some of these like mystical states that people enter into. Because so much of the field has been hyper focused on faster activity. And yeah, I think there's just like this is my bias, but I think we're focusing with this reductionist bias still to a big degree, and like the low frequency domain is just completely neglected as like the sleep rhythm and nothing more. So that's super cool, and yeah, I'd love to see that data for sure.
So could
Cool.
I comment on this a bit?
Fair.
I would say there are many authors that do not find what you mentioned at all. Unitive experience research from Aviva Berhom Johanna in Israel, no type of seizure-like activity at all. Or the Harris data, not at all. I have had similar things with very hypnotizable people, transcendent experiences, nothing like that. So I do not know that paper that you're talking about or that, but I would tell you that at least there are a number of authors that do not find that type of seizure-like activity.
If I could point out the Palva study, though, like in this study, they actually had to use a modified EEG system because a lot of like the baseline correction that happens online in EEG is like systematically deleting these ultra low frequencies because you need like a much wider dynamic range. So there also might be hardware limitations to using existing data to even look at that. But I'm also not making a strong claim. I could trust you, but yeah.
Quickly, I may have missed only high frequency, low frequency memory. How did you identify the apex with the low frequency oscillations?
Right now we have no data. It's coming. It's a good question. We're working on it.
Why do people think that the heart, the major oscillator in the body? How would you think that only the brain is the organ that we're able to raise consciousness? What are we looking at the brain? I'm a cardiologist.
Yeah.
I start a theory, a quantum cardiogenic holographic theory of the consciousness. I am a poster scientist.
So yeah, I really got to wrap up, but he's still copying his slides. Jonathan recently collected a concurrent EKG and then gastro electrophysiology, and so we're looking at some of these slower rhythms and maybe looking at some sort of whole body coupling of some kind. And also there's neurons everywhere, right? This little nuclei. Tam, final comment.
Yeah.
We have a special issue coming soon in Frontiers on the resonome and looking at basic dynamics of EEG and related modalities in different states, including waking, sleep, dreams, etc. So Justin's a great contribution in terms of fleshing this out as a framework here.
Let's give a hand to Justin.
All right, big round of applause.
See if we can do it through these slides themselves. So,
And our next speaker is Aramis Valverde.
hi, that is a better pronunciation than I can do. So while I set this up to distract the crowd, could I get a more or less, how many of you guys are doctors, medical doctors, anesthesiologists, that sort of thing? Okay. And how many researchers, just sort of generally neuroscience? Okay. Would you guys rather hear about anesthesia or visual perception?
Both.
I should have asked for the hands on that.
Does anyone know how to turn on presenter mode on PowerPoint?
Oh, we just have to make sure that it doesn't double it. There we go. And duplicate, extend, keep changes, Yay. Oh, there we go. All right. Hello, everyone. I'd like to thank the organizers. I'd like to thank you all for being here. I'm going to make pretty much the opposite case of what everyone else here has been doing. I'm going to make the case that neural circuitry and neurocomputational dynamics can explain most, if not all, of what we want to explain about the function, structure, and overall nature of phenomenal consciousness, which is a strong claim. And I'm going to have to lean on a bit of neuroscience to do that. I'm going to try to keep that minimal, though. Just as the cardiorespiratory system is a complex system, we're going to be talking about consciousness in those terms, about a complex dynamical system that has multiple aspects, but is ultimately defined by this sort of set of mechanisms, set of tasks and things that it does. That's pretty much it. We're mainly going to be talking about a cortical basal ganglia thalamocortical circuit and the mechanisms within that. And I promise it gets fun after we get past that. So key to this undertaking is treating phenomenal consciousness as a complex dynamical system. And as such, what I'm going to try to do is sort of shift our priors in a way that the other speakers have been trying to do as well. But instead of shifting it towards a monism, I'm going to try to shift it towards something called process ontology, which is just seeing things as, first and foremost, systems or basically things interacting, processes. And the reason that we want to do this for a system as complex as the mind is that you want to be able to sort of parse these things apart without having to lean on things that are a bit fuzzy, like does this thing have this property, does this thing have this state, right? We want to make things a bit more binary, and in biology it's a lot easier to just sort of check, is this dynamic happening? You know, is respiratory, is oxidation happening, that sort of thing. Once we touch upon process ontology, we'll do some neuroanatomy, then we'll go over the CSR circuit. And then I think everyone wanted visual perception. Could I get hands for visual processing? Okay, and for anesthesia. Okay. There were like 2 people over there that shifted that to anesthesia.
Do you want to stand more towards this side?
Yeah.
You're just in front of the thing. And then, yeah, the clicker works.
Yeah, no, it's just I have terrible vision and yeah. So process ontology, the idea that reality is best understood in terms of ongoing processes and not static objects with attached properties. Organisms are, in this view, ensembles of interlocking processes, developmental processes, respiratory processes, metabolic processes. You know, we can define a myriad of things that way, and that's what we're going to try to do here. A bit more of a mechanistic thing that will help pump the intuition is something like internal combustion or nuclear fusion. These are processes where there are structures that enable the thing, right? Like you need a nuclear sort of fusion device in order to get nuclear fusion as a process, but nuclear fusion as a process is not reducible to the machine. It's not reducible to the vacuum, to the supermagnets, to the plasma, etc. A sort of lower energy version of that is just to think of a flame. You need heat, you need something to oxidate, and you need oxygen. But those things in and of themselves, even conjoined, don't necessarily make a flame. It has to be a sort of like this ongoing, self-perpetuating thing. Right, so this is the circuit that we're interested in. That's very ugly, and why did I put this here? This is the nicer version. This is about as simple as I could make it. These segments are all quite a bit more complicated and nuanced. So the thalamus has projections to multiple subparts of those, and those break down in clinically important ways. So if you have a stroke that's a little bit over there, a little bit over there, you're going to get massively different things. And we can talk about that. Well, we would talk about that if we were doing the visual thing, but you guys like anesthesia. So we can touch upon it in the Q&A. So in the circuit, each modality has its own task. The anterior temporal lobe is proposed to carry out what is essentially semantic relational processing. And we have good reason to think that's what's happening there, which we can talk a bit more about later. So we know that the ATL is a semantic hub due to the legion of brain damage localization studies and neural imaging of all sorts that have been happening for decades. When you start having semantic dementia, you start losing meaning pretty much in lockstep with the amount of volume that you lose around there. Apple. Basically what it's doing is that there's a sort of overlapping set of representations, and we have good reason to believe that as well, that we can talk about later. When you think about Apple, there's a rough set of neurons, neural ensembles that activate sort of independent of any particular sense data. So there have been experiments which have demonstrated that if you close your eyes, I hand you an apple, you feel it in your hand, one part of the ATL lights up. If you smell an apple, same part lights up, so on and so on and so forth. Second, we have the prefrontal cortex. So anterior temporal lobe, just think of it as that holds the things and concepts. The prefrontal cortex is processing the semantic content and basically going, what good, what bad. So normally it's thought of as something that helps you reach goals and sort of prioritize things. Here, because of the connections to the basal ganglia and a lot of other reasons, we're conjecturing that what it's doing is basically saying what good, what bad based upon previous training. The basal ganglia over there is where the bulk of adaptive processing occurs. The striatum is the primary concern for the most important dynamics we're going to outline, so we're going to focus on that for a bit. It's proposed to instantiate a population code or map for the amount of activity or salient activity over a given amount of time. Basically, the striatum cares about how much stuff's happening and how do I feel about it. It calculates a bit of a valence based on a population code where it checks, well, am I doing better or worse than the thing before? And how's my trajectory going? Am I doing better or worse than before? And from that, it sort of sends out a new trajectory to the thalamus. The thalamus is constantly talking to the anterior temporal lobe, to the prefrontal cortex, to basically everything, helping modulate it to make sure that things are sort of going according to the evaluation of the basal ganglia and according to the sort of evaluations of every other part of the brain. Let's see if I can skip that. Yeah, that's pretty much the entire circuit. Let me go ahead and just give you guys the actual what it's doing. Basically, you've got your representations of multiple things, including the self over at your anterior temporal lobe. Your prefrontal cortex looks at the configurations at any particular point in time and says, what good, what bad. Basal ganglia processes that into a single signal that the thalamus integrates and broadcasts to the rest of the brain, and that allows dynamic processing to happen. And that dynamic processing becomes important later for explaining why we need a sort of phenomenology to actually occur as opposed to having nothing. So subjectivity is the thing that we all sort of care about, and one of the big issues that we seem to have had is that everyone thinks that subjectivity means 90 different things. So here I've broken it down into 3 kinds based upon that neural circuit. The first one is semantic subjectivity, or subjectivity in regards to the specific mental content that a person, mental content structure that a person is working with. Affective subjectivity, or subjectivity in regards to the particular reaction, effect, and dynamics that a given experience will elicit within the person, and the subjectivity that we care about, the one that's commonly associated with phenomenal consciousness, perceptual subjectivity. The specific evaluation by a neural system that it is a discrete thing which has experiences, a thing which is in some way or another distinct from the rest of the world and is currently having experience wash over it. Right now you might feel tired, you might feel, I didn't sleep, I'm dying on the inside. So that's the experience that I feel that's washing over me. Maybe you guys feel the same. In order to get perceptual subjectivity, we do unfortunately have to go through the first two, but I would run through it quickly. So, semantic subjectivity is the simplest kind of subjectivity to explain in relative terms. The model that we've been talking about, what we're calling the CSR model, a cortical self-representational model, proposes that semantic subjectivity, or subjectivity about what things are in what could be thought about as an objective sense, is attributable to the particular representational neural structures that are conjectured to be present within the anterior temporal lobe. Long story short, everyone's got different neural structures, and we have a good idea for what the sort of data structure in the cortex is, and we'll touch upon that briefly. This is work that I did in my first year, I think, during my half a PhD. So we attribute semantic subjectivity to what is essentially a directed hypergraph network. And how many mathematicians do we have? No, heck yes. All right, this is only for you. You might get something out of this, maybe, maybe not. The basic idea is that Henry Markram and a lot of other very nice people spent a lot of money slicing up bits of mouse brain, throwing it into a supercomputer, reconstructing it. And what people got out of that was not that much, depending on who you ask. But one of the things that they did find is that when you put a propagation through a simulated mouse neocortex, you get these nice graph-like propagations, and the entire network has this nice, clean, discrete sort of directed hypergraph structure. What a directed hypergraph is basically a network, but with very specific sort of like clustering that makes it very good at holding information. It's very good at doing relational information holding, basically. Won't go over too much detail here. There's a QR code at the end if anyone cares about this sort of thing. Maybe one of you will. Affective subjectivity is nearly the same phenomenon, but applied to a larger dynamic. So, what's happening with affective subjectivity is essentially your prefrontal cortex is getting the evaluation of the ATL. It evaluates the pattern at the ATL. Maybe you hate apples. I hate apples. I don't know why I have a problem. But apples are going to be sort of effectively evaluated by the PFC first, and then the basal ganglia is going to translate that into an emotion. There are people who are deathly afraid of dogs, for example. So we're going to be able to track, for instance, certainly at the sort of like lower level and to other neural processing areas like the amygdala, right? The sort of difference based upon that original bit. So you need the PFC in order to make these sorts of evaluations. Is sort of one of the things that we need to get out of this. This is entirely too far. Finally, perceptual subjectivity, the one that we care about, a bit more complicated. Long story short, I wrote entirely too many notes. So what's happening with perceptual subjectivity is that if you have a network that has multiple representations of many, many things, they're overlapping, you want to keep your representation of yourself separate from the other representations. You do not want to confuse, someone stepping on the ground for someone stepping on you. You don't want to feel threatened by that. And you want to be able to process your representation of yourself relative to representations of other things. You want to know how you exist in comparison to nuts, how you exist in comparison to Bank of America. And these are all calculations that you can make in the same way that you can compare you know, what an apple smells like to what an orange smells like, what an apple smells like, as opposed to a pear. So because over developmental time, you sort of end up with this prioritized self-representation, what you end up with is a system that basically identifies exclusively and tracks nearly exclusively a single representation that happens to track very closely with what gets sensory information. So one of the ensembles sort of randomly gets selected to have sensory information attributed to it, and as the network develops and gets differentiated, that's the one that sort of gets separated out, and it becomes difficult, not impossible, obviously, because you still need to calculate things, but difficult for that representation to bind with other things. There are ways of breaking that down, of course, on a molecular level, and that does have interesting effects later on. That's basically what acid is doing. So I have a slide on that later if people are interested in that, which I feel like people might be. So the basic idea is that phenomenal consciousness is doing a bit where it tracks how valence is changing over time, and it creates an internal, well, your brain and sort of this dynamic is creating an internal version of reality for you. That's the reason that you want to have something like that is you want to be able to train outside of actually experiencing things, right? Like dreams are useful because you can experience things that might otherwise kill you. You can get a fear out of that, the network can get trained. Similarly, if I see someone, you know, accidentally fall off of the forum, as I almost did last night, they were drunk. You might go, oh, I don't want to do that. Maybe I shouldn't have the third drink. So these are learning processes that you can go through without actually experiencing them. And the basic idea is that if we take the process ontological stuff and we combine it with this sort of understanding of what these neural systems are doing, we can do quite a bit. One of the things that we can do, which we won't be talking about too much, is plug that into existing things that we understand, like the visual processing circuit. Long story short, show me a lesion in a person, I can tell you if they're going to be able to imagine visually or not, if they're going to exhibit blind sight, that sort of thing, based purely upon what part of the circuit is inhibited or disinhibited. And that obviously has value. So there will be a QR code at the end for that. People cared about general anesthesia, so we'll cover that now. There was a lot of talk about the slow waves, right? So I was going to go over the molecular dynamics of that, but what we basically want to skip to is the good stuff. So with anesthesia, something like propofol, for instance, that's increasing the sort of limit of how much activation can go in with, and a neuron still doesn't fire. So what happens across the entire network is that the only propagations that manage to go through, the only thing that really activates a neuron are large waves. And that's what gives you those slow waves, right? And if you start thinking about consciousness as a sort of dynamic, as a sort of like ongoing process, it makes sense that at this point, when you start losing proper communication, you start losing the ability to differentiate signals, that you're not going to get consciousness anymore somewhere around here. Because at some point, it's just waves. There's never enough information being processed and moved about for you to get like a real ongoing dynamic. So propofol works in this way. Other anesthetics work in other ways. Xenon has a different profile than this, but it still causes anesthesia. We can track basically on, we've done 3 anesthetics so far, propofol, xenon, and ketamine. And with the exception of ketamine, what they've all done is disrupted the dynamics across one part of that circuit, the initial circuit that I showed you, and made it so that no complex signal can arise. Yeah, that's basically it. It's that circuit was not very well understood. Everyone, kind of wants and likes to research it. But the network dynamics have been a pain in the ass to work out. And a lot of stuff has only come out relatively recently. For example, all the molecular dynamics stuff that I kind of skipped over has only been available since this year. So, yeah. Questions?
Round of applause.
Time for 1 or 2 questions. I have a question if no one else does. Have you seen Earl Miller's recent study where he looks at different coupling patterns with anesthesia?
I'm bad with names.
Oh, okay, I think he has a keynote this week. Maybe we'll talk about it, but I don't know, just something to might be of interest. I mean, I don't remember the exact findings.
Yeah, something that you might find interesting was I did have a bit on binding that I skipped. So basically, one of the easy ways that you can sort of get binding, either from a system or just neuron to neuron ensemble, is reciprocate obligate firing. And that seems to track better than oscillations because there's the problem path, you get the oscillations, that sort of thing. And with the process ontology bit, insofar as you have one system that affects another system and vice versa, you get basically an integrated system. So that's a nice, clean way of differentiating whether or not something is or is not in consciousness. And that tracks onto things like blind sight.
Nice, cool. All right, one more round of applause. All right, our second to final speaker is Konstantin Anokin, and he'll be talking about the Cognitum, cellular encoding of subjective experience in neural hypernetworks. Yeah, I gotcha. Where's the mouse? Oh, there it is. All right, there you go.
Yeah. So, good evening already. And besides thanking organizers for this session and invitation, I want to say how much I enjoyed all the previous talks and how much I learned from them. A lot of overlap, a lot of differences, and obviously not enough time to discuss seriously. What would be excellent for the future sessions like this is to have more time for discussion. We need to go into depth with just a priming which we present in these 20 minutes and to discuss more. I will also start introducing myself. I'm also a neuroscientist. I studied for more than 40 years neurobiology of higher brain functions, especially particularly memory. And in the last 15 years, I moved to neurobiology of subjective experience through memory encoding subjective experience, and through that to consciousness. About 12 years ago, I presented a theory, which is a theory of high brain functions. It is not a theory of consciousness, it is a brain theory. But it has links to consciousness through a number of traditions in which it was developed. So what I will go through now is briefly through these backgrounds which was used to develop the theory, then briefly about the theory itself and ongoing projects. So the tradition starts from Pavlov, who studied conditioned reflexes with the idea how the matter of the brain produces subjective experience, which is exactly what David Chalmers presented as a hard problem 90 years later. However, the next step in the background was the idea that the reflexes, which Pavlov believed to be the physiological basis of the higher nervous activity, the term he suggested for studying the mental functions, are not sufficient and adequate to explain the operations of the mind. And another proposal from the student of Pavlov, Peter Anokin, was that instead the unit of integrative activity of the organism are not reflexes but functional systems. The functional systems theory was developed in 1930s through many experiments, starting from the classical Pavlovian conditioning experiments, going to plasticity of the nervous system under different conditions of anastomosis, developmental biology of integration of behavior during embryonic development and later on, introducing the idea of reafference as a feedback necessary for performance of adaptive actions which were not present in reflexes. The idea that the feedback is received by an apparatus in the central nervous system which stores the goal, the model of the result, and it is compared to it. And final operational architecture of the functional system. One particular line of research there was the neurophysiological studies of how the neurons integrate information in the cognitive operations, including, by the way, the idea that microtubules play an important role in the integrative activity of neurons. This line of research was extended into studying the dynamical activity of neurons in the animal brain with the acquisition of novel subjective experience, and showing that the neurons during behavior in the animal which was trained to particular tasks show the cognitive specialization. Here, for example, when the rabbit is trained to pull the ring in order to obtain food from one of the two feeders and two rings, or pressing the pedal, the neurons will behave and show the specialization towards either pulling the ring on any side or pulling the ring only on the left side, discriminating it from the right, or pressing the pedal only on the right side but not on the left side, or pulling the ring and pressing the pedal on the left side but not on the right side. So a huge zoo of cognitively specialized neurons corresponding to the elements of the subjective experience acquired by the animal. The difficulty was, however, that it was difficult neurophysiologically to study the whole functional system as a distributed ensemble of neurons during cognitive operations. We have developed in the end of 80s tools to approach this problem, initially looking for the genes which are activated in neurons due to acquisition of new experience. And we found the genes, one of them is immediate early gene C4, which light up at the moment when animal is having a new subjective experience. We showed that this corresponds to subjectivity of experience, so this has to be not a stimulus per se by physiological or sensory characteristics, but something which is absolutely necessary and novel for the animal to learn. And because this pattern of activity corresponds to neuronal ensembles which are turned on as units of new experience, then besides the electric activity which goes on in the whole brain with many neurons, only those which are involved in the particular type of subjective experience are labeled. So we proposed the idea that using expression of these genes, we can image the functional systems at the global level of the whole brain, ignoring the electrical activity and looking for those neurons which are involved into new experience, and making mapping of the whole functional system of a particular subjective experience in the brain. In order to do it in the whole brain level, we also developed the techniques to clear the tissue of the brain. Here's the mouse brain, for example, presented before clearing and after clearing. It is still present here, and it is 97% transparent, and developed the microscopy techniques to visualize the whole brain at the cellular level. So here is, for example, the mouse embryo imaged with this technique, allowing to do the cellular resolution imaging of the functional ensembles labeled by immediate early genes. We also used different transgenic models in order to introduce labeling into neurons that are active during a particular window of experience, and to be able to follow these neurons not only neuroanatomically in the brain, but introducing the optogenetic constructs to manipulate these neurons and to explore the effects on the behavior. So with this line of background, we moved from the Pavlovian conditioned reflexes theory and functional system theory to hypernetwork brain theory. I presented it in Taormina 2 years ago, so I will not go into much details without enough time. Just in a nutshell, according to the theory, organism as a cognitive system, so any cognitive agent to which we can apply the term who instead of what, consists of cognitively specialized elements which are present within this system. They are concentrated in the deep layers of the neural network and form a cognitive organ of the body, which we termed Cognitum. Cognitum has specific structure which can be approximated mathematically. I don't have time for this, as a neural hypernetwork. It's a mathematical theory from algebraic topology, the hypernetwork theory. And to the main identity, mind can be identified to this higher order structure of the brain and its specific causal properties, about which this is the slide. According to theory, the hypernetwork consists of nodes and links. Nodes are called COGs, cognitive groups, and they are represented by groups of cognitively specialized neurons, together having the cause-effect properties that are able either to see something in the environment at the level of the whole organism, and by their activity to affect at the next time step the relations of the organism with the environment. So important here is that these elements with their relational property as a group has a kind of a poor view of the relations of the whole organism with the environment. Links in the hypernetwork, in contrast to neural networks, are not connections between the elements, but the overlap of two cognitive groups on some of the common elements. So these common elements neurons are forming a link which, when activated within one cognitive group, can trigger the activity in the another cognitive group. So cog has double meaning in the theory. Importantly, it is a neural cognitive group whose activities sustain a specific experience. And log links of cogs reflect a specific feature of this connection, different from the neural network. Minimal cogs and logs are single neurons. That means that what can this group know collectively can be also represented by a single neuron, which has the perception of particular causes for the whole organism. That means cognitive causes of knowing what, and its activity can change the probability of the behavior of the organism at the whole behavioral level. With this model as a research framework model, we started studying the way how individual neurons are acquiring the subjective experience, starting with the classical cases like place neurons, asking the question when and what happens at the first instance of appearance of the place field in the hippocampal place field neurons. What organism perceives and does at this moment when the neurons are becoming cognitively specialized. And going to a more complex situations, here is the video, for example, where mouse with the optical recording with miniscopes of the calcium signals is interacting with neurons, and only fragments of video when the mouse is interacting are cut, and you can see that this neuron is specifically active only when the mouse explores this particular object which is known for the mouse. And here is the classical place neuron again. The video is showing only the moments when the firing of the neuron by calcium spikes is high, and you can see that the animal is at this moment behaving in a particular situation. So these are the experiments which we are doing now as a part of this project. And finally, in the last couple of minutes, I want to return back to yesterday workshop on the landscape of consciousness theories. Those who were yesterday at this workshop saw that Robert Lawrence Kuhn presented a website where he put together his previous work, the landmark paper on the landscape of consciousness. Now it is available. And he will speak also on 9th in more details. In graphical and abstract and browsing format. But what is striking is that this web resource presents 275 theories of consciousness. And the serious question, why do we have so many theories? One simple answer might be because it is important. For some reasons, people are fond of the issue of consciousness, like famous saying of G.B.S. Haldane that the Lord, nothing can be said about Lord, but only that he was particularly fond of beetles, referring to the fact that the beetle species are most widespread in the animal world. So 275 theories. But a second more serious question This is an overproduction. This is obviously an overproduction. What should we do with this amount? How can we cut it? Why, even with the extreme importance of this issue, people are not focusing on few leading theories like in other areas of science? Something is missing, producing more and more theories. And I believe that this resource can provide a platform for analytical work to see what is missing. And I think we have to have sessions on discussion how to cut down this overproduction. Thank you. Sorry?
No, sorry. I was asking if your contact info is there. I'll come and talk to you.
Yeah, sure.
We got plenty of time for questions. So.
How did you put that together?
This is a picture from the website, Landscape of Consciousness, which Robert Lawrence Kuhn will announce for the first time in a plenary session on 9th of July. This graphic exposure, as he explained, he worked together with the Iranian scientists, mathematicians, who proposed the graphical representation of relations of these 275 theories, how they are, by tensor lines connecting them, relate to each other. The size of these nodes represent the popularity of the theory, how much they are represented in the theory, in the literature, etc. But he will explain more on 9th.
So I love your question, why are there 275 theories? And I'll just offer another possible explanation is that there are 275, or probably more like 275,000 definitions of consciousness. I don't know that there's a whole lot of alignment on what people even mean by the concept. Certainly, I just stepped in from the AI session upstairs, and being able to distinguish terms like consciousness, intelligence, artificial consciousness versus artificial intelligence or simulated intelligence are all terms that I don't know that people are really fluent in. And that might be another reason why they're, at this moment, need to be 275 theories of consciousness. And like I said, I suspect it's probably considerably larger than that. Those are just the documented ones.
Yeah, that might be a symptom of a problem, that we do not have a good... Two comments. I'm submitting this week, working here also in the hotel, 2 chapters into Handbook of Neurology. One about neurobiology and neurology of memory. And it is clear-cut. All the divisions and in the chapter sections, it's easy to do. And the second is about consciousness. And it's completely different coverage, though we have neurology of consciousness, but it starts with the problem of how we do comparable to memory and classification of memory types. How do we define consciousness? This is number one. So there is a specific problem, I agree, in the field of consciousness definitions. And second, my approach is most of the theories which are presented here, they have some working definition of consciousness. They start from how do we define consciousness in order to work. The theory which I proposed goes the opposite way. It says, let's get rid of all even working definitions. Let's look in the brain at the higher causal level, the level which is still don't understand because we view the brain mainly as a connectome, as a neural network. These are not the highest causal level of the higher nervous activity or higher cognitive functions. If we will understand the brain at this higher level, perhaps we will come to new terms and notions which we can compare to the existing terminology accumulated over hundreds and thousands of years by empirically looking at something which is hidden as a hidden reality named by different terms. And we can compare then the scientific theory of the brain with its potential to what the common sense definitions are and to see whether there is any correspondence. So moving from other direction.
Since nobody raised their hand, and I love the topic, an interesting thing to explore in addition to what you just said is to look at where people feel like they're experiencing higher levels of consciousness. And many people who have had those experiences talk about it not being in the brain at all, but being in the heart, being in other parts of the body, or in fact not being in the body at all. So it's absolutely an area that's wide open for open-minded exploration and really good science.
I agree. I think that our session is an example, as well as the whole conference, of the open-minded exploration. It is very different from the traditional academic conferences, and it gives an advantage of this open-minded exploration.
Thank you so much.
All right, our final speaker is Jonathan Schooler, and his talk is titled The Kite of Consciousness and Other Metaphors of the Mind. Let's welcome Jonathan.
Thank you. One of my favorite quotes is, theories are like toothbrushes. Everybody has one and nobody wants to use anybody else's. And I think that may be especially true for consciousness research. But today, instead of, well, I will be talking about theories, but I'll also be talking a lot about metaphors. And one thing that we're oftentimes encountering are mixed metaphors. We'll burn that bridge when we come to it, and so on. And oftentimes we are advised against mixing metaphors. But today I want to promote the mixing of metaphors. I want to argue that for complex issues such as consciousness, different metaphors offer sort of different angles onto the topic. And so rather than trying to constrain to a single metaphor, I'm going to introduce you to a whole lot. Actually, a number of them have already been introduced if you were here for Justin's talk earlier on. But some of the metaphors that you'll be encountering today include consciousness as a theater, consciousness as a conversation, consciousness as a mosaic photograph, where when you zoom in, you see that each pixel is itself a photograph, and that can then be zoomed in and see further pixels within those photographs. And then some fresher ones, consciousness as a dimension within a 3D space. And I'll also be talking about consciousness as going up a down escalator. And then, of course, you can anticipate consciousness as a multi-paneled kite. Okay, so here we go. Put on your seatbelts. We're going to go through a lot. So I'll go through this quickly because Justin already reviewed it, and hopefully many of you were here for that. We have a paper that came out recently called Hierarchical Consciousness, the Nested Observer Window, which introduced three sort of central metaphors, the theater, the dialogue, and mosaic tiling. Very briefly, the idea is that the mind is constituted of theaters, and each theater may in fact be a locus of consciousness. So one of the things about this model is the possibility that your mind may have multiple theaters going on, but the top theater, as Justin mentioned, is the apex. And the key thing that defines a theater is that all of its bits are essentially happening in entire synchrony. This is also aligned with a model with Tam Hunt, in which you basically have a integration of everything because it's all happening simultaneously in a particular locus of activity. Then we have a dialogue where you have the where you have coupling between one source and another source. A conversation is a perfect example of a dialogue, but the idea is that the mind itself is constituted of these windows that are communicating with each other. So that you can think of this as the left hemisphere and the right hemisphere, different, the amygdala, or even internal family systems. And then the third is, and this is perhaps the most original of the three, is the mosaic tiling idea, the idea that we have multiple hierarchically organized windows, and that the windows are communicating with each other through cross-frequency coupling, where you basically have rhythms that are overlapping in harmonic manners. So this model invites you to take a look at the paper that came out in Neuroscience of Consciousness. But what today I'd like to do is to integrate that model with another paper that came out in Possibility Studies and Society called The Three Dimensions of Time. And this is a even more speculative model that tries to introduce some ideas about how to relate consciousness to physical reality and to some of the issues that have come up in physics. And it ends up speculating on the possibility that there may be, in the same way that we talk about three dimensions of space, there may in fact be three dimensions of time, subjective, objective, and alternative, and I'll unpack those. But let me start by stepping back and inviting you to sort of think about what are the self-evident truths of your own phenomenal existence. What are the things which, if you just popped into existence, they would seem self-evident to you? And this is very much like the activity that Descartes engaged in when he was imagining demons sort of playing tricks on him. What are the absolutely inescapable, or essentially the axioms of our experience? And I want to argue there are four. This is, again, with Justin, but interestingly, there are sort of these four axioms, although I find them all axiomatic, I actually hold them in decreasing level of absolute certainty. So the first one is absolutely certain, the next one is nearly certain, and so on the last one is a little bit more marginal. Okay, so the first one is experience happens, that experience exists. I might be a brain in a vat, I could be in a simulation, but I'm having a experience. The second one is experience is necessarily a unfolding. It's one moment after another moment after another moment. That experience could be the exact same experience, but it's happening in a succession of outcroppings of flow. The third is that experience is always in the now. I might be remembering the past, I could be imagining the future, but I'm always doing that in some circumscribed period, which we refer to as now. And then the final one, and I admit that this one is a little bit less certain for me, but it's very compelling, is that experience is impacted by our decisions. I'm able to direct my attention over here. I'm able to direct my attention over there. It's an absolutely fundamental aspect of experience, is the sense of control. What's interesting is that these four self-evident truths have no place currently in mainstream science. So the occurrence of experience itself is the hard problem of consciousness. I don't have to tell this group that we've made very little progress on that. And there's a lot of people who are illusionists who essentially argue that consciousness itself is an illusion. Daniel Dennett was among them. The flow of time, you may not appreciate this, but in physics, the flow of time is considered an illusion as well. As Paul Davies said, nothing in known physics corresponds to the passage of time. Indeed, physicists insist that time doesn't flow at all, it merely is. We experience the flow of time, and yet somehow that's an illusion. The present is also considered an illusion. As Albert Einstein famously said, people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. And then finally, of course, science has long dismissed free will as being an illusion. You have the illusion of free will, but in fact the illusion comes about because you just don't know the future. So, and of course, the notion of free will seems to be against notions of causality, making consciousness some sort of primary cause. So let's first ask the question, why do physicists reject the flow of time and the privileged present? Why do they think this, the experience of now is an illusion? And the answer has to do with something known as the block universe, which comes out of relativity theory, in which it's basically time is treated as another dimension of space. And so the past, the present, and the future are all just different locations in this block universe. That means that you are in every moment, past, present, and future, and so there's not a degree of freedom for you to move through the block universe. So this is the way that you experience an event, but in the block universe, all those different moments are all there simultaneously lined up together, so there's no way to move through it. They're all already there. So herein lies the rub. Science provides absolutely no way of conceptualizing the four most self-evident aspects of experience, of existence. Experience, the flow of time, the uniqueness of now, and free will. And we argue that this means that we should maybe just relax our assumptions a little bit and think about, are there other ways of thinking about these aspects that might be able to integrate into mainstream physics? So it suggests the need for scientific humility, and it raises the likelihood that we'll need to find a place for subjectivity in its foundation. So how might we do this? What's missing in the current view that might enable us to introduce subjectivity into the mix? And our claim is that a critical thing that's missing from it is the degree of freedom to move through the block universe. Because time has already been used as one of the dimensions, there's no degree of freedom to move through it. We need an extra dimension. So perhaps we need to postulate the possibility of additional dimensions of time. And through the introduction of additional dimensions of time, this may enable consciousness to move through physical time. So let me show you what I mean here. First, I'm positing the idea of an additional dimension of time, which may seem like a really outlandish thing, but if you think about it, it's very intuitive to think about we have chronologic time. That ticks along with absolute regularity, but then subjective time does not tick along with objective time. Sometimes time goes fast, sometimes time goes slow. Sometimes we don't have any experience of time at all. For example, when we're under anesthesia. When we're in an accident, time seems to go very slow and so on. So this notion that there's a subjective time which is different from objective time and could be thought of as somewhat orthogonal dimensions seems, I think, more intuitive than it might be at first blush. So if we introduce the possibility of a subjective dimension, so now we can move through objective time relative to subjective time, and that allows us then to move through the block universe. Let's see, that should.
You come back to it.
Okay, thanks. Okay, so let me introduce you to a diagrammatic way of doing this. So I introduced you to the block universe before, and in the block universe, before we had physical space reduced from 3 dimensions to 2 dimensions, here I've reduced it just down to 1 dimension. And so we've got physical space and objective time. And here's the observer. And notice the observer is in every moment simultaneously. So there's no way for the observer to have a flow of time because they're everywhere simultaneously. But if we introduce a subjective time dimension, now the observer has an extent in subjective time relative to objective time and can actually move through objective time relative to subjective time. So by introducing an additional dimension, that provides successive moments of now, so this gives us a now, and it also gives us a flow of time. We can also relate this to the block universe. So here, each different moment in subjective relative to objective time corresponds to another frame in the block universe. So by introducing this additional dimension, we're now able to move through objective time. And then you can also imagine different observers who have a different frame rate. So this relates very much to your model. Different frame rates. Some have a faster flicker rate, and they're maybe with less information in every frame, and others have a larger extent in every frame, but they are taking slower steps. So it allows us also to have multiple observers moving through subjective relative to objective time at different rates. Okay, so I've promised you 3 dimensions, and so far I've only given you 2, subjective, objective. What might be the 3rd dimension? And here I want to suggest the possibility of alternative time. Now this relates in some ways to many worlds' theory of physics, in which an interpretation, and this has become an increasingly prevalent interpretation of quantum effects, is a splitting universe. And essentially, you maybe have heard about the cat, where in one version the cat is alive and the other cat, the version is dead. And according to this model, the universe is constantly splitting. So you find a dead cat, one version of you finds a dead cat, and another version of you finds a live cat. And this is actually the most unparsimonious model ever invented, because the universe is constantly splitting off into multiple universes constantly. At the same time, it does sort of work mathematically. So the intriguing possibility is that perhaps at every next moment there are multiple possible alternative, sort of an implicate order, but we only go down one of the different branches. So the alternative is that essentially you're imagining this observer window, and it's able to rotate in alternative time and in one way or the other choose between the different tracks. So this then provides the possibility that consciousness could to some degree, select between alternative futures, and thereby providing room for free will. Okay, so this then leads to a model of 3 dimensions of time, in which we're doing pretty good, in which we've got a subjective time, and we've arbitrarily aligned the time dimensions with spatial dimensions, but this works for now. Invite you to try different variations of it. So basically, we're making subjective going up, objective going forward, and an alternative going left and right. So it's a little, you can imagine you've got this window which is basically able to rotate in these 3 things. And so basically, here's a window here. The more the window is having a steep, the more it's sort of leaning back, the more steps it's having in subjective time relative to objective time, and so time goes slower. The more it's leaning forward, it's going slower in subjective time relative to objective time, and so that might be something like having a very deep conversation, whereas leaning back is like having a car accident, and then left and right is choosing between different alternative times. And then we can build in the nested observer window model into this, where we have the apex at the top. The apex, as Justin was arguing, is going slowest, and ideally it would be facing sort of the least tilt, and then all the lower ones are having different angles. And then you can also imagine that the slower ones are actually, the lower level windows are actually ahead in objective time relative to the back window, and that explains how we're able to integrate all the information. So all the low-level systems have to make their judgments and experiences before the back one makes its final resolution. Okay, time for our final. No, we got 2 more metaphors to go, and 4 minutes to do it. Okay, so right now we have the windows moving through time. But instead of having the windows moving through time, we can switch it and instead imagine time moving through the windows. And so this is like going up a down escalator. Time is basically coming at you. You're staying still, but time is coming through you, and you're basically shifting your angle in time. And so this notion, if we now take all these windows and have time moving through them instead of them moving through time, that brings us to the kite of consciousness. So this is basically the notion that we have essentially all the windows are all fixed together. They're sort of tethered together, and you can imagine time is like the wind blowing past them, and each one of them has its own degree of freedom to be able to move, but the whole kite is nevertheless moving as a whole. And we're still working on the graphical depiction of this, but this is a first presentation of that. Let's see if this will move. It should. Oh, yeah, here we go. Oh, there we go. Okay, so here you can see the flashing, the lowest level is flashing the fastest, corresponding to the faster frequency, and then it's got the most steep angle, so it has more of an angle in subjective time relative to objective time. Time is moving through it. We can do that one more time. And in principle, each one of those different windows has its own degree of rotation in alternative time, and each one is integrating from up to the next levels up. So we're sort of working on this model, but essentially the idea is that all of these different windows are tethered together. Each one has its own potentially independent axis in alternative time, which allows it to basically integrate a tremendous amount of information and flexibility. So some of the key additional speculations of this final metaphor of the kite of consciousness is first, rather than us moving through time, time is moving through us. Secondly, the windows are all tethered, so that even though we're all moving together, we all have some impact on one another. And potentially the movement of every window impacts the movement of the entire substructure. So even an individual window is influencing the entire kite structure. And in principle, each one of us, so far we've been treating each one of us as the apex, but of course each one of us could be a pixel and yet a larger level window, or we could be essentially all part of this giant kite, all tethered together, and so the movement of each one of us may be influencing the movement of the entire kite of consciousness. And indeed, like I said, even though we're sort of thinking of ourselves as the apex, we might not be the highest level. There could be apex above us, but that apex shouldn't get too full of itself, because it could be just a pixel and yet a higher level apex. So there's a sort of intrinsic humility to this model. And it is interesting to note that there's a sort of fractal quality to the universe where nerve cells and galaxy clusters show a substantial resemblance. So in summary, I introduced I re-summarized the now model, which had the metaphors of windows, conscious experience defined by synchrony, conversations between windows. Windows at the same level communicate by coherence. The mosaic photograph. Windows are nested and communicate up and down the hierarchy through cross-frequency coupling. And then additional metaphors, 3 dimensions of time, which correspond to the 3 dimensions of space. Windows move through 3 dimensions of time, objective, subjective, and alternative, analogous to the 3 dimensions of time. I suggested going up a down elevator rather than us moving through time. Time is moving through us. And lastly, the kite of consciousness. A consciousness can be thought of as a multi-paneled kite with objective time likened to the wind passing through it. Thank you all for your attention. I'd like to acknowledge various co-authors who are here, my various affiliations, and grant support. And I'd welcome questions if we have any time. Yeah, in the back there.
Thank you very much. I'm Radar from Finland, and at Aalto University, we're formalizing memetics, rebooting it essentially, so that it finally becomes a formalized discipline. And as a part of that work, it's quite clear that the structures that we're modeling, since it's purely formal, I mean, it's abstract. It's about abstract representations. Out of that works come very clearly highly compatible thinking with what you're doing. I love your poetic approach, and I've never seen anyone talk about this quite like this, but just purely formally and structurally is exactly what memetics is about as well, because just shortly, it's of course about the fact that we have the world out here, and inside ourselves we have representations. Whatever we have here is in here because it's represented abstractly inside us somehow. Now, out of that, of course, comes the fact that the space, the state space or space of representations can easily accommodate, and actually, without going into details again, it almost presupposes the fact that it has its own time. So there's nothing weird or odd or exceptional. I think it's quite logical and natural. And then finally, that of course neatly conforms to the fact that there are forces in that space. For example, if we feel attraction, then that's in my mind. It's not like my body in this physical space is suddenly drawn to another person physically. Something happens in my mind, but there are forces. There is attraction, repulsion, etc. in that space, and that presupposes time and forces, etc. So it all neatly falls into place. Just saying out that. So super interesting stuff, and I'd love to talk more.
Yeah, terrific. Let's talk about them more. I just would want to add that oftentimes I'm treating these dimensions as metaphors, but the real agenda is to have people take seriously that there's an ontological reality to these, that this is not just sort of a metaphor for, or that subjective time is not just sort of a metaphor where objective time is the real thing, but they actually are ontologically on par, if not actually subjective time having the upper hand, because we absolutely have, we know that subjective time passes. We don't even really know about physical time.
I got that. I'm not there yet, but when we talk more,
right.
Perhaps I'll be there.
And I'm not there. I'm entertaining that too. But we'll go with Arno.
I have a question about the free will. So in the hierarchy, it's like only apex has free will, but now there's something about the
everyone.
Apex. So if everyone has free will,
yeah,
and there's like almost infinite hierarchy, then nobody has free will, right?
No. So basically, the idea is that in the most sort of extreme, radical version of it, the idea is that every individual window has consciousness and has free will, and maybe some other imperatives like curiosity and valence and preference. And each individual window is making its little turn in every moment, and that then influences what the next level up gets. So the decisions of the lower level windows are then impacting the decisions of the next level windows and impacting the decisions of the next level windows. And those then are shifting and impacting back and forth. So everybody has free will in the kite of consciousness. Yeah.
Possibly a short question, but why do you have a preference of time moving through us versus us moving through time?
They're actually, so in one sense, it's sort of an arbitrary thing. But in the other sense, and this is something that I need to work through with someone with more mathematical skills than me, the idea is that each one of the individual windows has got its own axis in alternative time. And then if we're all tethered together and time is moving through us, but each individual one has its own axis, then it actually introduces multiple degrees of freedom for alternative time in all the different systems, whereas if we're moving through time, then each one would have to scatter out in its different direction. So having time move through us allows us all to stay tethered together and potentially have additional freedom in this alternative time dimension.
All right, I'm going to cut it off for the sake of time, but if the speakers can hang around a little bit and answer additional questions. So thank you all for your attendance.